Hello everyone, this is Muhammad Abib Khan recording a demo video for my FYP titled Enhanced Video Frame Interpolation using a Hybrid CNN-GAN Framework. So essentially, frame interpolation is generating a middle frame between two frames to increase the FPS of video. It has many applications, including but not limited to gaming, sports broadcasting, surveillance system, medical imaging, and video post-processing. So in this FYP, I propose to first implement two traditional methods, Lucas Canade and Gunnar Farnberg, optical follow estimation, then interpolate the frame using these two methods. And the third one was to develop a CNN-GAN framework and demonstrate how deep learning frameworks have improved this specific tasks. So more details will be of course be available in this documentation. So I'll just go through the shared folder, the contents of the shared folder. So this is the folder that is shared in the drive link. This is the GitHub repository link. This is the progress report one that was submitted, and this is the proposal. So the main code folder is here. I have provided a README which goes into details about the contents of the folder and how to run. But in short, the frame utils has two files. The frame.py is a Python file. This file deals with essentially creating frames out of videos, then creating video out of frames, and separating the ground truth from the interpreted frames, etc. So this file has that stuff. Then we have metrics. This code basically calculates PSNR, peak signal noise ratio, and SSIM's structural similarity metrics to basically provide a conclusion where if the results have improved or not. Okay. So Gunnar Farnbeck, obviously it has gf.py, the implementation of frame interpolation using Gunnar Farnbeck optical flow estimation. And so it's a dense optical flow estimation, and the details and the results all have been mentioned in the documentation. Then we have Lucas Canade. It has optical flow .py as a file, so it contains the implementation of Lucas Canade after with frame interpolation using Lucas Canade optical flow estimation. Then we have the real ESR again. So this is the let's first go over super slow-mo. Then super slow-mo we have SCNN based model for frame interpolation. So we have the data folder here. So you would place the model checkpoint here. I provided the links to download in the README file, and then we have the eval and model file. The main file is eval. So you run this file to generate your results, and then real ESR again is the GAN part of the CNN-GAN framework. And in the waste folder you okay, so it is a weights file. I will remove it just so that the file size is ideal, and you can download it. I provided the links as well in the README, and this is the main file that you will be running to generate the results. I have provided sample usage as well in the README documentation, in the README file. Okay, so realize again it has some dependencies files. You don't have to run these, just this main file. Okay, so the data folder, now it also has a README. It basically, the data folder contains the original data files and all the results from all three implementation: Lucas Canade, Gunnar Farnbeck, and then CNN-GAN framework. All the details have been mentioned here, what files contain what. But I'll just go through them once again and show you the final results as well in this video. So we have the original video here. So this is the 360. You can hear the audio right now in this, but it had the audio. Then the videos that I work with, obviously I remove the audio. So this is a 360p 640 by 360 video. The original video around 25 frames that I worked on. It is a car going through, a single car going through a drift track in a straight line. Then this is the car low video. It essentially has every odd number of frames removed from it. So this video is around 12.5 frames per second, down from 25 to 12.5. So now we apply all our optical flow estimation frame interpolation techniques on this video. So this folder original frames has all the original 173 frames of the 25 fps video, from the 25 fps video, and then the ground truth has all the odd frames that were removed from the low, like car low video, the car original that that are missing from the car low video, so that we can compare the or interpolated frames with the ground truth. And then the low to 12 fps has all the odd missing frames, so we can generate the video for the car low. Then the Lucas Canary has the Lucas Canary implementation, the results. No, not the implementation is called. This is the only results. So we have a text file here. It mentioned results, remarks, etc. We have the interpolated frames. These contains only the frames that were interpolated. And these are the high 25 fps. These contains both the original frames and the interpolated frames. So like 001 should be the interpolated frame here, 0 and 02 should be the original frames, and 001 is the interpolated frames. You can see, and using this folder this video was generated. Now I'll show you the video as a demo. So you can see the fps have been increased, but obviously it is a estimation using a old method, Lucas Canary, sparse, so the results are not that good, but it's as an implementation as a base mark to compare against a CNN-GAN framework. Then we have the Gunnar Farnbeck one, same structure essentially, high GF. We have the interpolated frames, high 25 fps, results mentioning remarks, results, and parameter set in some cases. This is the interpolated video with increased fps. We can see the struggles in the area where the shadow changes rapidly, where the sun through where the sun shines through the trees. So we can see the implementation struggles here a lot, and but overall at the starting it was a much better result. The more everything in detail will be written in the documentation. And then we have the CNN-GAN framework. So we have multiple things here. First of all, we have the high 25 fps video. So this contains the CNN part, the output of the CNN, and of course every odd frame here is interpolated, which is and all that odd frames are presented here again in this interpolated frames video. Then I applied GAN on it, and now each original frame and interpolated frame, sorry, this contains only the interpolated GAN frames. So on all the interpolated frames GAN was applied, and to obviously I created these interpolated folders so that you can compare it against the ground truth easily. So you can essentially regenerate all these folders using the frame.py. I've commented out the lines, but you can essentially recreate all these folders from the videos, etc. Then we have the results GAN. This have the GAN applied on the original frames and the interpolated frames together, so that I can get this car high video. So car high is the output of only CNN model. So we can see it's quite nice, quite better, and we can still see it struggles a bit here, like here. where there's a rapid shadow changing, light and shadow changing, but it is still much better results. And you can see that the FPS have been increased back to 25 again. And yeah, then we have car high GAN. So this has the, okay, so there are two GANs here. One is no upscale and one is upscaled. The one that I just talked about, like the results GAN is results is here, car high GAN, and this one is upscaled to 4K from 360p to 4K. So not only is the visual quality improved, the resolution is also quite improved. You can see here it's now 4K at 25 FPS, and you can see how smooth and bright and red it looks. And you can see the artifacting has also been improved, but it still couldn't fix the stuttering, like the issue at the rapid changing lighting there, because the CNN model SuperCinema still works on optical flow, and optical flow assumes that the brightness is same, so it still struggles a bit, but it is still much better results, and it is fairly a lightweight model. All these calculations were done under a minute or two on my system processor, not a GPU, and the specifications of the system will also be mentioned in the documentation. So obviously we can achieve much better results with a much better model, and which takes more time or a dedicated GPU to run. And then the same GAN model, but it is not, this one is not upscaled. And you might ask why I did that. I only did this to compare the results, the metrics, because the PSNR and SSIM both are pixel wise calculations, so I couldn't compare the results with from the ground truth with this with this GAN applied upscale video, because the pixels have been increased. So essentially our GAN model works better than what the results will show in the documentation, because there's no way to compare both of those. But yeah, so the results GAN no upscale has all the original interpolated frames with no upscaling, and then the interpolated frames no upscale has only the interpolated frames with no upscaling. Pretty self-explanatory, and still all the details are mentioned here, all the results are mentioned here, and all the details again will be mentioned in the documentation. For reference, wait a second, that's about it. I've gone through the GitHub repo, the progress report, the proposal. I will be placing documentation in this folder. It is currently not here, like it is here, so I'll be placing there and sharing that, and the link will be available in description and uploaded in the forms as well. Yeah, that's about it.